Have you ever watched Inception? Maybe you have. Did you understand Inception? Me neither. But in Inception, there's a really interesting concept that's introduced in the movie. So basically there's this group of thieves, and what they do is they travel into people's unconscious minds and traverse down the layers of their subconscious to steal secrets. Their subconscious is represented through dreams. So going deeper means they're going into a dream within a dream. They're dreaming inside of dreams, hence the name Inception. You can think of these dreams as dream layers. Once they hit the layer that has the secret, they've basically hit where they need to be, and they just go back up the layers of dreams by waking up from each dream. Funnily enough, this can actually be used to explain a really complex but interesting topic, probably one of the most confusing topics in all of APCSA. Welcome back to LearnAPCSA, and today we're going to be discussing recursion, which covers topics 4.16 and 4.17. So when I say recursion, what I basically mean to discuss is recursive methods. These are basically methods that you can write in a class that inside the method makes a call to the same method. Now, I'm sure you're all familiar with what the Fibonacci sequence is, but if you're not, I'll explain it really quick. It's a sequence of numbers starting from 0 and 1 that takes the previous two numbers of the sequence and adds them together to make the next number. The first number that we take in the sequence is 0, the second number is 1. So the third number in the sequence is 0 plus 1, which is 1. The fourth number takes 1 plus 1. The fifth number takes 2 plus 1, which is 3. And it keeps on adding the previous two numbers and creates an entire sequence of numbers called the Fibonacci sequence. We can find exactly what number is at a certain index position in the sequence just by writing a recursive method in Java. So imagining the Fibonacci sequence as an array of ints. Using this, we can create our entire sequence of numbers. So our method will have a parameter, which is the index of the sequence that we want to find, and it'll return an int, which is the number that is at that index. We can say 0 is at index 0, and 1 is at index 1. So if the number that we're given in the parameter is 0, we can return 0. If the number given in the parameter is 1, we can return 1. It's only when it gets past 2 that we start to encounter problems. So we can use recursion here. Let's imagine the number we're given isn't 0 or 1, it's actually 5. So the fifth index in the Fibonacci sequence is just the third and fourth indexes added together. We can find these third and fourth indexes by calling the Fibonacci method. It'll find that 3 isn't equal to 0 or 1, so we find Fibonacci 1 plus Fibonacci 2. Then Fibonacci 1 just equals 1, and Fibonacci 2 is equal to Fib 0 plus Fib 1, which is 0 plus 1, that's 1. 1 plus 1 equals 2. Fibonacci of 3 equals 2. So we know what Fibonacci 3 is. What about Fibonacci 4? Well, Fibonacci 4 is just equal to Fibonacci 2 plus Fibonacci 3. We already know what Fibonacci 3 is, even though the computer will have to compute that again. And we also know what Fibonacci 2 is because we calculated that separately. Fibonacci 2 is equal to 1, and Fibonacci 3 is equal to 2. 2 plus 1 is equal to 3. So Fibonacci 4 is equal to 3. Fibonacci 3, which is 2, and Fibonacci 4, which is 3, add together and they create 5. So now we know what the number at the fifth index of the Fibonacci sequence is, and all because of recursion. It just calls the method over and over again until we hit something called a base case, which are these, checking if it's equal to 0 or 1. Otherwise, we go deeper into the method. We keep on calling this Fibonacci until we can hit this base case. Base cases are super necessary for writing recursive methods. Without them, we run into something called a stack overflow error. This is a runtime exception, so it's not something your compiler is going to detect as you're writing the code. Imagine you're in Inception and you're looking for a secret. You keep going down the layers of the subconscious, but the secret isn't there. This person doesn't have it in their mind. So you keep going deeper and deeper. Eventually, you get to the point where you can't wake up from that dream. That's what's called a stack overflow. So when the stack of recursive methods keeps on going down with no end in sight. Eventually Java will detect this and it'll just throw an error at you and stop running. So we know at least one base case is required for a recursive method to run properly. What else is required? Well, of course, our recursive call, which is just the call to the method that we're in. Otherwise, it's not exactly recursive. Now, although you don't need to write recursive code, you do need to be able to read it and understand what a method call to it would return. So, understanding the strategy to reading and solving recursive problems is absolutely essential. What I just showed you earlier with the Fibonacci problem is what I call a table approach. You map out all of the calls that are being made and what is returned by those calls. If it's just the method again, then go deeper, write what that call returns. Then you work your way back up the stack. It's a little bit difficult to keep track of in your mind, so that's why I highly recommend using this table approach when you're solving problems like that on the test. Okay, this is cool and all, but why do we use recursion? Well, to be totally honest, it's just really simple, concise, and nice to read. All recursive methods can be written iteratively, or just like a normal for loop, as you've seen before. However, with recursion, you can make it a lot simpler and easier to understand, even if it's not intuitive for you right now. Recursion can be used for a lot of things as well, such as traversing arrays, or searching and sorting. One sorting algorithm that's notorious for using recursion is merge sort. Merge sort basically uses a method called the divide and conquer. What merge sort does is it divides an array repeatedly over and over again until each sub-array is its own one element array. Then from there, it recursively merges all of these sub-arrays into sorted arrays over and over again. You can see a visualization of this on the right. It doesn't always have to look like this, but what you need to remember is that it does this recursively. If you're like me, this is still difficult and hard to understand. It's just like Inception, you don't really get it the first time. But trust me, practice will save you on this. Use the approach that I used for the Fibonacci problem that we had, and try to approach more recursion problems, things that will challenge you. Thanks for watching once again, bye!